Hello, in this video, we're going to talk about the state transition matrix. And the main question in this video is to find the long-term probability in certain states. So here we have a matrix and it has input 0.25, 0.75, 0.5, and 0.5. So what does the numbers in the matrix mean? So let's look at the first input, 0.25. It means given we have 0 at time t, there is a probability of 0.25 that we will end up at 0 at time t plus 1. And for 0.75, it means given we have 0 at time t, there is a probability of 0.75 that we will end up at 1 at time t plus 1. And you can apply the same logic to the rest of the numbers. Now, my question is, what if we want to find out the probability at time t plus 2? The answer is very simple. We multiply the matrix by itself. And that means we're squaring the matrix. And here we got our new matrix. The new matrix shows the probability of states 0 and 1 at time t plus 2. Now, what if we want to find out the probability at time t plus 3? Yes, we just cube the matrix. And here are the answers. Now my question is, what if we want to find out the probability at time t plus n? Yes, we just raise the matrix to the power of n. Now I want to ask, what if we let n to approach infinity? So the result is that the value of the matrix converges to certain numbers. And here the numbers are 0.4 and 0.6. So this means in long term, the probability of state 0 is 0.4, of state 1 is 0.6. However, this way of finding the long-term probability of certain states is not very efficient. This is because we have to multiply the matrix by itself for infinite amount of times, and that's impossible to do, and that's very hard to do. So I would like to pose a question, is there a better way? So in the rest of the video, we will try to discover an efficient way of finding the long-term probability of these states. So first of all, we let pi to be a row vector that takes the long-term probabilities of these two states, which are 0.4 and 0.6. And this pi row vector has a very special property. When the pi row vector is multiplied with the state transition matrix, the answer is itself. And by the way, if you don't know the name, the pi row vector is an eigenvector. So now we got some hints here. We can set up a general vector p0, p1 in this way. And then we just solve for p0 and p1. But how can we do it? First of all, we have to transpose the matrices. And by the law of how the matrix operates, we have to switch the positions of pi row vector and the state transition matrix after we have transposed the matrices. And then I will bring the pi vector on the right hand side to the left hand side. Since the right hand side becomes a 0, I will just put it as a 0 matrix. Now we have to take the pi vector out. And on the inside, we're left with an identity matrix. So now, I will just do the calculation and find the answer out. At this stage, you can choose any equation to be 0. I will just choose the top one. So we have negative 0.75 p0 plus 0.5 p1 equals to 0. And from here, we know p0 equals to 2 over 3 p1. And by the way, we also know that p0 plus p1 equals to 1. That's because the total probability always equals to 1. And if we sub in our values, we find out that P1 equals to 0.6 and P0 equals to 0.4. And this is exactly the same result to the one when we multiply the matrix 4 n times. And in the end, I will give you the formula. The formula is pi times p equals to pi. Pi is the row vector, and p is the state transition matrix. And remember to switch the order of p and pi after we have transposed them. In the end, thank you for following along to the end, and thank you for watching my video.